If my PowerPoint will ever open up. There it goes. All right, linear motion. We'll go over motion as relative, so the relativity of motion, speed, velocity, acceleration, free fall, and vectors. So let me ask you something. How fast are you moving right now? You're not moving? So, is the Earth not going around the sun right now? Or are you flying out into space stopped as you watch the Earth fly away? Is the Earth not spinning on its axis right now? Is the sun not moving around the galaxy? Is the galaxy not flying through the universe? Motion is relative. Motion of object is always described as relative to something else. For example, you walk on the road relative to Earth, but the Earth is moving relative to the sun. So your motion is relative to the sun. So your motion relative to the sun is much different than your motion relative to Earth. Relative to Earth, you're not moving. Or I should say, relative to the rotation of Earth, you're not moving. Relative to the center of Earth, the Earth is rotating on its center axis. Speed. You probably all have covered speed before. Speed is defined as the distance covered per amount of travel time. How comfortable are y'all with the metric system? It's unfortunate, but in physics we use the metric system. If you've never seen a meter, this is exactly 1 meter. So we will be doing speed in terms of meters per second. So 1 meter per second would be traveling this distance in exactly 1 second. The equation for this is speed is equal to distance divided by time. A girl runs 4 meters in 2 seconds. Her speed is 2 meters per second. Make sense? And if I go too fast, tell me to back up. So, average speed. Average speed is the total distance covered divided by the total travel time. It doesn't indicate various instantaneous speed along the way. So if you wanted to calculate your average speed you travel to Lufkin, take how long it took you to get there, the total distance, so you take the total distance divided by total time, that gives you your average speed. Instantaneous speed would be what your speedometer says. Are you currently driving 55 miles an hour? Are you currently going 75 miles an hour? That's instantaneous. Average speed is looking at the total distance and total time divided by the total time. So if you drive a distance of 200 kilometers in 2 hours, your average speed is 100 kilometers per hour. So the average speed of driving 30 kilometers in 1 hour is the same as the average speed of driving what?
60 kilometers per hour.
Yes. So you can look at this as 30 divided by 1. So we need to find the same ratio. 30 divided by half is 60. 30 divided by 2 is 15 kilometers per hour. 60 divided by half is 120. 60 kilometers divided by 2 hours is 30 kilometers per hour. So you're looking for something that has the equivalent of 30 kilometers per hour. Instantaneous speed is the speed at any instant. When you ride in your car, you may speed up, you may slow down. The speed at any instant is normally quite different than your average speed. Your instantaneous speed is given by your speedometer. So this is speed. So y'all probably all encountered speed before, right? You probably covered it in previous science classes. Speed equals distance divided by time. We're going to be using velocity. Have y'all ever heard of velocity? I mean, have you ever used it? So velocity is both the instantaneous speed, so it's a speed component, but it always has a direction. So velocity is a description of both the instantaneous speed and the direction of travel. Velocity is also a vector quantity. Have y'all ever done vectors before? So vector is going to be, so a vector has a magnitude. The magnitude is a value. So magnitude is going to be speed, and direction is going to be what direction it is. Velocity is always directed. So magnitude is going to be the number in units. Direction is going to either be north to the right, 30 degrees, some indication of direction. Now, even though we're going to be using velocities, usually I'm going to be lazy and not write a direction with it. But you should understand that velocities always have a direction. What we do if we don't put a direction is we assume that the velocity is going to the right. So I would write that down. If you write a velocity without a direction, you assume that it's going toward the right. If horizontal, are going up if vertical. So I will actually switch. Actually put that in words. My computer is acting very slowly today. So if you leave off direction on velocity, we often assume positive values point either to the right or up. And it depends on whether or not we're referring to horizontal or vertical. We will mostly be dealing with velocities, but having you write over and over and over again, going to the right, going up, is something we usually just leave off because it's understood. We usually will say like a car is moving and not give a direction. Then, so if no direction is given, you assume, so if no direction is given, we assume positive values are moving forward. Or whatever the original direction, the initial direction was. So if no direction is given, we assume positive values are moving forward, and or whatever the initial direction was. And of course, negative would be the opposite. Negative would be to the left or down, or are backwards or going in the opposite direction. I will say this, if I do give a direction, you should write it down on your answer. So if I say, for example, a bus was moving 35 degrees northwest, then your answer should include whatever direction it was. So usually, if the question doesn't give you direction, you can leave it off. It's probably referring to speed anyway, but we still like to call it velocity because we like to be more precise. So, but you need to understand that speed and velocity are different. Velocity always includes the direction, even if we don't actually write it. So constant speed is steady speed, neither speeding up or slowing down. Constant velocity is a constant speed and constant direction. This is where the main distinction between speed and velocity is. If you are driving 55 miles per hour and you make a left turn, your speed stays 55 miles per hour, but your direction is changing. Because your direction is changing, your velocity is changing. So you can have a constant speed, but not have a constant velocity. If your direction changes, your velocity changes. And that is something that's very important in physics. Initially, we're not going to be dealing with changes of direction. We're mostly going to be dealing with just the magnitude of velocity speed. But do keep it in mind that velocity also includes the direction, and if direction changes, the velocity is actually changed. Motion is also going to be relative to the rotation of Earth. So whenever I say something is moving, it means like it. You would think it's moving. Y'all said y'all were not moving, it's because y'all are measuring it from the surface of the Earth. So unless otherwise stated, we are going to treat motion as relative to the surface of Earth. So again, constant velocity means that you also have a constant direction, a straight line path with no acceleration. Acceleration is formulated by Galileo based on his experiments with inclined planes. You don't have to know about Galileo. I don't test over him. This is a history class. Rate at which so acceleration is the rate at which velocity changes over time. So does acceleration depend on a direction? So acceleration is based on the rate of velocity. If it's the rate of velocity changes, and velocity includes the direction, acceleration has to be direction. So velocity and acceleration are something we call vectors. A vector, so let me actually write that down. All right. So a scalar is just a number and units. A vector has a magnitude. A scalar so it has a scalar value. So a vector has a scalar in it, which is just a number with the units, and also a direction. So when I say something is a vector, note that it's just like a normal scalar number or value. And a vector adds a direction to it. So speed is a scalar, and velocity is a vector. Y'all good? So acceleration occurs whenever there is a change in speed or a change in direction, or both. So a car making a turn. What is changing whenever a car goes in a circle? Its direction. Wherever direction it's facing is constantly changing, so it's constantly accelerating. So the equation for acceleration is the change in velocity divided by a time interval. The units of acceleration are going to be the same units as velocity with an additional time unit. So what all alphabets do y'all know?
ABC.
What's the name of that alphabet system? Do y'all know?
I call it ABC.
It's not the name of it.
One alphabet.
What do you think? Think back. What was a group or language that we derived English from eventually? Where almost all languages derive from?
Latin.
Latin. We use the Latin alphabet, or your ABCs. There's only 26 lowercase letters and 26 capital letters. That is not enough letters to do physics in. You will also be learning the Greek alphabet. Alpha, beta, zeta. You know it? Have you ever seen Greek letters? I'm sure you've seen some of them. So by the time this class ends, you will know almost all the Greek letters. All right. So acceleration we let equal to A is equal to a change in velocity divided by a time interval. You might notice something. What do y'all notice? There is a symbol here. Has anyone ever seen that symbol? Want to make a guess what it is?
Triangle.
Not a triangle, it's a letter, an alphabet. So this is acceleration. This is change in. This is velocity. And this is time. So this triangle is called delta. It is the Greek letter equivalent to a capital D. It means in physics change in. So delta V, change in velocity, is equal to the differences of velocity, Vf minus Vi. So if I say that you're filling up you're filling up a water bottle, I asked you how much water did you add. You take the final amount of water and subtract it from your initial water level to figure out the difference. As all this means is the difference between final velocity and initial velocity. Whenever we read this, you can either say VF or final velocity. Note, this is called a subscript. So, that is called a bigger subscript. It describes the variable. So, and VI, so the I stands for initial, so it would be initial velocity. Does that make sense? Have I lost any of y'all so far? So acceleration is your change in velocity, how much you've changed by, in a given time interval. I will go and write this because this doesn't. Alright, so common measurement, so acceleration units. Let me put velocity first. Velocity, and I'll do distance. So distance, will we mostly be using meters, which is an M. Velocity, we will be doing meters per second. So what would acceleration be? If acceleration is a velocity divided by time, and time is in seconds, so time is in seconds, or S per second, what would acceleration be? So acceleration takes a velocity and divides it by time. So it would be meters per second. This is the equivalent to meters per second squared. Acceleration always is going to have a distance. So one distance unit and 2 time units. So I could also have done maybe, let's do miles per hour divided by seconds. This would also be an acceleration. So we have a distance divided by an hour divided by seconds. Does that make sense? Units are very important. Being able to tell that this is an acceleration value based on units is something that you're going to have to work at and learn how to identify. We could have also, so right here, so instead of miles per hour per second, I could have done miles on top, basic math, divided by an hour times a second. This is the same thing as that. These two are identical. Dividing miles per hour by seconds, you can rework that fraction. So this you can break out as miles per hour times 1 divided by a second, and then group the denominators into miles divided by hours times seconds. So your car speed may presently be 40 kilometers per hour. If your car speed 5 seconds later is 45 kilometers per hour, The change in your speed is 45 minus 40, or 5 kilometers per hour. You changed your speed by 5 kilometers per hour. Your car's acceleration is thus 5 kilometers per hour divided by 5 seconds. So 5 divided by 5. Note in this PowerPoint is trying to signify that that's an error. It's supposed to have a divide by 5 seconds there. So, I can't do that. That's supposed to be 5 kilometers per hour divided by 5 seconds. So an automobile is accelerating when it is doing which of the following? So acceleration is basically a change in speed, or it's a change in velocity. So when are you accelerating? So change in velocity it'd be slowing down. Also change in direction, so there's a change in speed in our direction. So change in speed, either increasing or decreasing per time, is acceleration. Change in direction is also acceleration, even if speed stays the same. Acceleration and velocity are actually what? No, velocity is dealing with, so they're both rates. So velocity is the rate at which distance traveled over time, distance traveled changes over time. So velocity tells you how much your distance is changing over time. Acceleration is telling you how much your speed or velocity is changing over time. Also direction too. So I'm not going to really go over, let's see. I'm going to stop right there and work out some examples. All right. So we can write, so we know that velocity is going to be equal to the change. It's going to be distance divided by time. And we have that acceleration is going to be equal to the change in velocity divided by time, or VF minus VI divided by T. So this is basically your speed plus a direction. And acceleration is going to be how much the speed is changing. Another way of writing this is velocity. How would you measure distance? So let's say that I plot an XY coordinates. Y, X. How would I figure out the length of this line? Have y'all had geometry? So I'm going to choose the initial X. I'll call it XI. And I'll do XF. So this is the initial X point. And this is the final X point. So the distance, D, the length. So distance will be equal to the change in X values, or XF minus XI, right? That's how you solve for length. So another way of writing velocity, and we call X, we call XF final position, or final X position. Sometimes we leave position off. So we can write velocity as the change in X position, or our distance. So we can let delta X be change in X, or simply just call it distance. We're going to do this for a very long time. I know this is a lot of information to you right now, but we're going to go over it and over it and over it and over it for until December. So I know this is a lot, but as I continue moving, you're going to eventually get all this down. So let's do an example. I should probably have put V equals delta X over T. Trying to get rid of the names. So we have V equals delta X and A equals delta V over T. So velocity is a change in position. Acceleration is a change in velocity. Suppose you went from 5 meters to 15 meters in 2 seconds. How fast are you moving? Five meters per second. When solving these problems, I suggest identifying variables. So this is your initial position. So this is your, and we often use and think of everything being horizontal or to the right. So this is your initial X position. This is your final X position. This would be your time. And again, in physics, we mostly think of it in terms of math. So I would actually, whenever I look at word problems, I identify the numbers and then almost completely forget about the math, or English, completely overlook the English. I have an XI, I have an XF, and I have a T. I know that velocity is equal to delta X, is the change in X, So we have xf minus xi divided by t. And all I have to do is plug this number in. So how fast you're moving is referring to velocity. So that would be 15 minus 5 divided by 2, which would be 10 divided by 2, and that'll give you 5. Make sure on your final answer, so these were in meters, you include seconds. Also, it is very important because it will trip you up. If I were to put 5 seconds, do not write 5 seconds like that. Oh, sorry. Do not write it like this. Looks too much like a 55. Your units should be smaller. It just makes it more legible. Even though I know I don't have the best handwriting, I absolutely have to make the seconds really tiny and so for me to see them. So let's do one more example. Let's see how much time we have. Okay, we have 10 minutes. And do tell me, I can't really tell whenever I'm going off the screen when writing. So let's see. So you're traveling at 55 miles an hour and you come to a complete stop in 5 seconds. What is your acceleration? So let's look at our equation for acceleration. Acceleration is your change in velocity divided by time, or vf minus vi divided by t. So in order to solve for acceleration, we need a vf, a vi, and a t. So here's our first number. What does that correspond to? VI, your initial velocity. 5 seconds. Identify your numbers. That'll be your T for time. What about VF? 0. So complete stop corresponds to VF. So we have VI is equal to 55 miles per hour. VF is equal to 0 miles per hour, and time is equal to 5 seconds. Plug it into our equation. Acceleration is equal to VF minus VI divided by T. That would be 0 first, 0 miles per hour, minus 55 miles per hour divided by 5 seconds. That would be negative 55 meters, or 55 miles per hour divided by 5 seconds, which would equal negative 11 miles per hour per second. This value tells you you are losing 11 miles per hour every second. So you were slowing down. You start at 55 miles an hour. Every second, you're going to lose 11 miles an hour until you come to a stop. So 1 second goes by, you're now going 44 miles per hour. Another second goes by, you're now going 33 miles per hour. Another second goes by, you're going 22. Another second, then 11, until you finally stop at 0 miles per hour. So this is the math, and this is it written in English. So our acceleration is negative 11 miles per hour. Most of this entire class is going to be this. I will give you a word problem, identify your variables, identify what equation you should use, and then plug those numbers into the equation and solve mathematically. It should be straightforward. Again, this is something that's going to take practice. We're going to go through a lot of examples. So another one. So you travel 600 meters in 1 minute. How fast did you travel the distance at in meters per second?
10 meters.
Yes. So being more formal, and I suggest even if you can just look at it and know the answer. So 600 meters. You can either realize that this is the change in x. So you can realize that the change in x is equal to 600 meters. Or you can make an assumption that your initial x position is 0 meters. Your final position is 600 meters. And then we can do delta x, which is equal to xf minus xi, which would be 600 meters, minus 0 meters, which is equal to 600 meters. So you can look at either equation, either the simplified, so your velocity is equal to delta x divided by t, or if you wanted to do it strictly in xf minus xi divided by t, you can look at these variables. Or time is also 1 minute, which is equal to 60 seconds. So when plugging it in, velocity would be equal to 600 meters, which is your delta x, or change in x, divided by 60 seconds. 0 cancels out, that becomes a 1, so it's 10 meters per second. Make sense? Alright, tomorrow we're going to go more into this. So these are the first 2 kinematic equations. There are 2 more, and we're going to go way more in depth with the kinematics. But for the most part, this is going to be the first test. There's just 2 more additional equations. Relatively simple. So no questions?